Hello everyone, my name is Akash. I am giving a talk today on deploying framework agnostic libraries, network libraries using Tanstack. I know this is sort of a wordy title, but what we are doing today is sort of very interesting, especially if you work with your own libraries or do any front-end related stuff in any framework actually. So yeah, my name is Akash. I work as a software engineer at SigTech, which is a quant. We are hiring. Reach out to me if you want to apply. And you can find me online at my website, thewriting.dev. And yeah, so let's start with what is Tanstack query. So you must have heard of React query. The guy who created React query, he wanted to do the same for most of the frameworks out there. So he just used his own name instead of React. His name is Tanner something. And so yeah, that's how we got Tanstack query. And so yeah, why should we care about Tanstack query? So firstly, as I said, I guess this answers more of what Tanstack query actually is. So it is a cross-framework asynchronous state management solution. Basically, it helps you make fetch API calls better. And how does it do that? It does that. Yeah. So if you actually go to the website, this is what all of the benefits it says there are for using Tanstack query or like React query or whatever over making native API calls. But what does this mean at the end? Like all of these are basically buzzwords for marketing, like backend agnostic, dedicated dev tools, whatever. So in the end, I think it's three things which actually matter. One of them is auto fetching. Tanstack query takes care of when should an API call happen on a page. Basically, it happens whenever you are actually on the page and making the API call. It has sort of a caching solution we'll go into in a bit. And whenever that cache is stale, it can automatically refetch if you want to. Or if you go to a certain tab on your browser or like go do something else and come back on the page, then it will make that fetch API call again. So that keeps your data on your page updated and you don't have to worry about all of these solutions whenever you're building your own libraries. The next thing is mostly auto caching. Mostly because, as you know, caching is a difficult problem to solve. In Tanstack as well, you have to sort of pass your own key to make sure that your cache invalidation works correctly. And yeah, again, we'll go into details about what kind of solutions Tanstack offers and how you can configure it, but not into too much detail. And the last thing is state synchronization across your app. So if you make a fetch API call in one component and you make the same API call in another component, it will use the same cache, and that is again because of the auto caching nature of Tanstack. And you can also configure it to not do that if you wanna, but I mean, if you would mostly want to keep that like it is. So what does this mean to you? I mean, like, what does this mean to the average developer? We just talked about a bunch of features. So firstly, there's loads of really useful things out of the box. So whenever you're creating your own network library, some examples down there, but I'll come back to that in a second. You get all of these benefits out of the box. So think of any network library like Fast API or Express. I mean, why do you use those libraries instead of writing like native HTTP servers? Because of all of the benefits you get out of it. Secondly, I think that's the most important bit. You don't need to learn platform specific things. So there are a bunch of frameworks out there nowadays: SvelteKit, Next.js, Nuxt, and many others that we learn about every day. And Tanstack is optimized for each one of them. It has native libraries built for each of them. So you write your you write your library mostly once, and then it's sort of optimized for all of them. You just have to make small tweaks, but you don't have to worry about state effects or whatever which is happening in those libraries. And thirdly, it's not just for network requests. So if we look at the tagline for Tanstack, it says that it is an asynchronous data management library. That means that wherever you do any sort of asynchronous operations, which basically means promises in the end. So anything involving promises, you can use Tanstack with. So this involves, if you're building a Reddit client, for example, so you can use Tanstack to optimize the responses for that using cache or whatever, so your users don't get rate limited for the queries that they're making. You can use it to build a Twitter client, or you can use it to build your own. So I use this for Rocket RPC, a library you might have heard about sometime. And yeah, that's how I got introduced to Tanstack, because I didn't want to build a network library for every single framework out there. I just wanted to build it once and then optimize it for, or have it auto-optimized for the rest. So yeah, that's all the introduction that you actually need to understand Tanstack. Let's get into the actual code now. So Here is a default code example of I mean, here's a default code example from the Tanstack documentations itself. Here we can sort of see how you can configure a web page to use Tanstack correctly. I'll sort of go into how this web page works, I mean what this web page is actually doing before going into the details of it. Basically, this is querying one of those placeholder APIs which generates a bunch of random data points for you to do code examples. So in this case, it's using one which generates posts, and whenever you click on a post, it like returns some data points for the post itself. So this is more useful with the developer tools on. So yeah, Tanstack does come with its own developer tools, which is sort of interesting. And we can see, I'll refresh this page. Oh, that's taking a little bit. So yeah, when the page is loaded for the first time, it makes an API call to posts through Tanstack query. So what Tanstack does is that it caches that result in the cache, the result for posts. Don't worry about whatever is in the quotes there right now. That's just like the query key which is being set by the developer. In this example, they might have set posts as the query key. And whenever we go into a post, it caches the posts as well. So we can't exactly see that it's making a API call and then returning that, I mean like it's loading that data. But if you see there for a second, it's sort of going into loading. So whenever we go back into a page which has been already cached, then it doesn't make that API call anymore because that data is still hypothetically fresh for us. But there's one thing which Tanstack does for us, which I talked about, which was cache invalidation. So you can sort of set a timer. If I go into the docs quickly right now for cache, yeah, it should be here actually. This one. So yeah, you can sort of configure, even though I haven't really talked about how this works, you can sort of configure about like you can set certain parameters for invalidating your cache. In this case, they've just set it to stale time. So whenever a second expires, it will just make an API call whenever you go back to the page again. So if we go to this page, hypothetically, it should make an API call again whenever you go to another page and come back. I guess if we have a look at the inspect element, and if we go back here, stay there for a second or so, I guess, and then come back. Yeah, you see that it makes another posts API call because the old data was invalidated and it tries to refresh the latest set of posts on the page again. Again, if you don't want this behavior, you can change that. So this is like the dev tools that Tanstack provides. It gives all of the data. It tells you whether your data is stale or not, and you can use this to debug any of your queries. And this is, I mean, this was how that page works. Now let's go into the code of what actually happens here. Firstly, like most JavaScript libraries nowadays, you have to define a provider. Why this happens is because on the top level, I mean, you are defining one provider, which is basically this line number 13 here, and then you are passing it down via a context. And then whenever you are making a query via use query, which is the main hook that you use in Tanstack, that use query hook is internally going into the context provider, getting the original client, and then storing all of that data. That's how it does automatic caching, data synchronization, etc. throughout your app, because it's all going through one single client, even though it looks like we are calling a different hook at every point. And yeah, so the first sort of page that we are looking at basically is this posts one, and then there is a, I mean, this is basically the renderer for the posts. If we look at use posts here, that is using the actual hook. So use query, this is what you will be using most of the times. This is used to make queries to any data like via fetch requests or whatever. So it only consists of two things. I mean, it doesn't only consist of two things, of course, but these are the two things that you will be using most of the times. The first one is the query key. This is how caching happens, and this is why I said it's mostly auto caching, because you still have to have some amount of control over the cache. And the second one is the query function, what actual function is executed whenever you use this use query call. And so this is just returning the use query results here. And what are the things that you can deconstruct out of that? So in this case, it's status, that might be the HTTP status. Yeah, they've sort of abstracted it away to error, success, and loading. There's the actual data, the error, and whether it's fetching or not. So for the posts, we can see it's, I mean, you can sort of see the syntax going on here. It's the query key and query function. And for getting each individual post by ID, it's doing the same again. So it's just passing the query key, which is post and post ID. So this is actually very interesting, this bit, because for query keys, Tanstack does a deep compare and it doesn't care about the order of the elements. I mean, it cares about the order of the elements within this array, but it doesn't care about the order of the elements within this array, as in, like, if you have an object which is sort of like A1 and B1, and then if you have another object which might have these elements in a different order, it won't care. It will still try to compare them, and it will still cache your results correctly. So it isn't like use effect or whatever where you have to worry about whether the reference remains the same or not. And yeah, just trying to undo that. So in this way, you can sort of build a very complex query cache. I mean, a key for a cache which can consist of multiple objects, multiple arrays, whatever. And it just makes our jobs easier because we don't have to worry about like creating a unique key every time. And again, like, this is just get post by ID. As I said, this is just using some random JSON placeholder API and then doing that. So yeah, we just saw an example of making API calls via Tanstack query. Now let's look at a different example where we use something which is not just API calls via a fetch request, I guess. So in this case, this is a very simple example again, which is using Tanstack query and a library called Octokit REST. Octokit is the official GitHub API client, and I mean, even though it might at some point in the end be making fetch requests, it doesn't really matter to us because it returns a promise. And in this example, what I'm doing is I'm just constructing an Octokit client here via use memo, and then passing a method to use query which returns like the results of a repo called Octokit REST.js or whatever. And if we go to the actual web page, oh wait, so this is not the web page. I think it should be, yeah. So if we go to the web page, then it makes the API calls, returns that data via data, and then we are displaying the data being returned from that query here. So this is just an example that it works outside of fetch requests as well. And then in response here, I'm doing data.data. This is sort of weird because Octokit returns a data object in its result as well. So we have to do data.data there. So okay, this is all right. I mean, what I was talking about at the start was that you can use Tanstack query to optimize any of your network libraries, right? So, but this doesn't look like optimization. I have to write this weird code every time again. I have to use query with any API call that I'm making. Well, we can sort of optimize that, and this is what the main sort of function of my talk is. So what if we could optimize Octokit in such a way that whenever you are making an API call via Octokit, I mean, not an API call, but like a GET call or whatever via Octokit, it automatically wraps use query over it and then returns all of the results that use query would provide without you actually having to use the use query hook. I mean, it would actually use it under the hood, but you wouldn't have to worry about it. So is there a way to do that? So yes, there is a way, and we are going to do that in the code example today. So yeah, luckily I am in the demo directory right now, and let's try to optimize this to make it like, I mean, whenever you're using any Octokit query, it should automatically call use query inside of it. So firstly, what should we do? I guess the first step would be to make a hook called use Octokit or something, which would return the actual Octokit, what should we call it? I guess client. So I guess I don't really need to export this. I'll just call this const Octokit or whatever, and then this can just return this, right? Probably using a use memo because we don't want to create a new one on every render. So this would do something like return use memo, and then I don't know, this return new Octokit. And this doesn't really take any dependency params, I guess. If it does, then React will complain about it, so we don't really have to worry. And then we just use our hook here. So this is sort of the first step. Let's have a look whether the page still works the same. Oh, I should probably go to demo here. Yeah, so it's still loading the data, so we haven't broken anything yet. So we'll continue to make changes till we break something. And what's happening next? So it's using use query here. And how are we using use query? So we are passing in to query function this octokit.rest.repos.whatever. So who here knows of a way how we can modify the results of an existing object to return something else and to make our own queries on it? Do you know what it's called, like whenever we are building middlewares for objects? If you answer this correctly, I'll buy a drink for you at the pub. Sorry?
I probably will repeat the question.
So how can you modify existing objects, any existing object, like in JavaScript? I mean, there's a native construct for it. How can you modify existing objects to modify their result? Like whenever you are getting a certain parameter from it or making a function call on it, how can you modify its result?
Are you talking about the prototype?
Sort of prototypes, I guess, isn't it? No, not. I mean, I guess that might be something which I'm not aware of, so you might be right. But observe, you know. No, so the answer is should I give the answer? Yeah, what was your first point? Proxy, yeah. So, I mean, I had this here, so you guys should have known, but yeah, it's object proxies. You can use object proxies to modify any existing object. So this is what we are going to use here right now as well. We are going to return a proxy instead, and we are going to use that to modify existing objects to do whatever we want instead of what it actually is supposed to do. So we won't really worry about TypeScript here right now. I have a very complex type built out for this. We'll have a look at it if we have time. But what I want to do right now is sort of create, I mean, I just called it client proxy because I'm not very original, but we need a method which recursively goes into a proxy and sort of returns data. This will start making sense as we go into it. So I will create a new proxy here with some target, and this target, let's say we take from the parameter here. Again, don't worry about it right now. And then what was the syntax for it? I think, oh, it's the second parameter which takes the traps. So yeah, what is the syntax for a proxy? Helpfully, TypeScript has displayed what it does already, sort of. So a proxy takes a target, like which object are we doing actions on, and then it takes a handler. So the target object is whatever we pass in to sort of modify. So that is what makes proxies generic. So you can use it with the Octokit object or like any of your own clients as well. Or like in this case, I'm trying to make it generic, so it can be anything. And the handler is basically certain traps that you can set on a object. So for example, if someone is trying to get a property, so let's try to deconstruct what's happening in this line in terms of object proxies. Wow, so this is sort of becoming object proxy tutorial right now, but that's fine. Yeah, so we have two traps that we need to use mostly. So the dot operator is a get trap because we are getting a property that's same as object.get or whatever. And object proxies are so useful that even if you deconstruct this object and you try to get on it, it will still use the correct trap. And then the next trap that we have to sort of use here right now is the apply trap. And the apply is basically function call trap. Whenever it reaches here and it sees this, I mean, I don't know what it does internally really, but whenever it makes a function call, it uses the apply trap. So those are the only two traps that we are worrying about here right now. So I'll just use get, which is a method hopefully. I think it is, yeah, and then apply. So yeah, what do these do? So since I just sort of described that, it does octokit dot, so dot is a get trap. So what do we do in the get trap? Let me look at the TypeScript parameters for here. Yeah, so basically it accepts the target. So this target, it gets passed down to get through that parameter, and then p, which property is being accessed. So in this case, whenever someone does octokit.rest, the target becomes octokit and the property becomes rest because it's trying to access the rest property on it. So what we can do in this case, I'll just do target and property here. So we just return a new proxy. And why are we doing this? The way object proxies work is that you can't really, the way JavaScript works, I guess it's not even object proxies, is that you might know that every single bit in here is a different object, right? Because this is basically, you have a parent object which has its own reference, Octokit. It has a child object called REST with its own reference, and there might be a bunch of other objects in there. And then REST has a nested object inside of it called repos, which has its own reference, and so on. So whenever you are creating an object proxy, you are only doing it on the root element, and you need to do it for every referenced element inside of it as well. So that's what we are trying to do here by returning a new client proxy whenever a user is trying to access a property. So
Sorry, I just started. Why are we doing all this? What are we trying to achieve?
so we are trying to recursively get into Octokit here right now. Any object basically, and we are trying to get into its final dot operator stage. So this property, what we are trying to do is wrap get in query function, right? We don't care about the rest of it. We just want to get to get. And how do we get to get? That is by recursively iterating on.
You say get a lot.
We are, so yeah, this could be anything. Let's call it fetch, repos.fetch. So we are.
So why are we trying to get to that function?
Because that's what we are trying to optimize via use query.
Okay. So we are trying to provide a query function.
Yeah, we are trying to make this generic. Like, we shouldn't have to write this whole statement every time we want to,
If we use different Octokit APIs or different APIs.
Yeah. If we use different APIs, it should still optimize for it, I guess. Yeah, that's what I'm trying to do. No worries. So yeah, it should target property. So again, like, TypeScript complains a lot because proxies don't really have any types. So don't worry about it. So whenever we are using get on something, we just recursively called client proxy on the property which was being called. And what we are actually what we should actually worry about here is the apply method. And apply method, this is what the real juicy bit for this is, I guess. So the first property it takes is target, and the second is something that we don't worry about. The third one is the arguments list. So this is basically arguments. It's sort of auto-completing it there, but not exactly. Okay, I might have misspelled it somewhere. So yeah, so target and arguments list. And so what have we just done right now? We have created a generic way to get an object method. So target, if something hits apply, it's a guarantee that it is going to be a method, because otherwise a developer wouldn't really be calling a function over it. So we know that target is a method right now, and we also have the arguments list for it. So what we can do is we can sort of make the query function a bit more generic right now. And in fact, what we can do is we can actually optimize this, and we can directly use query here. So at this point, I can just return use query from here, and the query key, as we were saying, the query key can be anything. So I'll just create an array which accepts target and arguments list, and then React query Tanstack query takes care of everything for me. I don't really have to worry about creating a unique query key here. The second thing we want is the query function. So we can do target and triple dot arguments list. I actually need to make this anonymous, because otherwise React will call this at every render. And then hypothetically, I should be able to call this, return this from here. I think I'm missing some.
The base case for the recursion, that is always going to be record. The tail of the recursion is not needed here. We will just, when you reach undefined, that is fine.
Sorry, can you repeat your question?
You're going to call recursively, like
Yeah.
all the time. You don't need a tail for the recursion, some base case for which
So,
you finish recursive.
Where it finishes, yeah. So apply is a base case here, and this doesn't really go infinitely. This only recurses if you are calling the get trap or an apply trap on a proxy. And if you are calling something else, like you're setting a property to it, then it won't really call anything, and then a new proxy doesn't get created. So there's no, I mean, I guess I can't say that it can't go on infinitely because of the halting problem, but hypothetically it shouldn't be able to do that. So yeah, I mean, we sort of have created a generic method in which we can sort of wrap any object and then it will optimize it using use query for us. But let's check how this works here. I think I just, sorry?
The Octokit instance will be inside a client class.
I mean, you could do that, I guess, but what we need here right now is to return this using this basically. So what this does right now is it returns an instance of the Octokit client, but a proxied instance of the Octokit client to the front end.
So the Octokit client is now a dependency.
Yeah. So as I said, it will vary about it by itself. So mixed dependencies change, move it inside a use memo. So I'll just.
I think you can just put the Octokit client inside the same use memo, so you don't need to do references.
Yeah, actually that's right. Yeah, I could do that. So yep, and then wrap this inside a use callback. I was expecting that because I mean helpfully we don't have to worry about it because React does that for us mostly. And then have a dependency parameter on this which doesn't really accept anything, I guess.
I have a question. Does the client proxy, does it need to be a use callback and it just not be a function? Or because you use query inside?
Yeah.
So use query will need to be a dependency, right?
I'm not sure exactly. Let's have a look at what this does. So function implicitly return type. I think if I just do this here, yeah. So now use Octokit is actually using a proxy on top of this, and let's try to console log its results. So we have this method which we were using, and if we try to console log it, I mean right now the TypeScript for this will be borked because it's just returning any from it, but I have a solution for it which I can show later. And then it should be a dot data. Actually no, let's try to console log this and see what ends up happening. And I'll just sort of comment out the rest of it so it renders correctly. Yeah, and if we go back here, inspect element, go to console. Ooh, okay. I guess I will need to sort of use a dot data here, I guess. And yeah, we can see that it returns the correct results. Yeah. So it returns it inside of dot data. So it returns the correct the results from there. Yeah. Anyways, what I wanted to showcase was that now we have created a generic way of wrapping any object with use query. So this doesn't just work with like octokit.res.repos.get or whatever. Now we can wrap any different method with this as well. So for example, octokit dot wait, this doesn't have type completions, but I'll just do that here and then paste that back in there. So octokit dot users dot find get by username. I'll just paste mine in for now. So if we go back and paste that in there and then do a dot data at the end, again this can be, I mean all of the results that use query returns. So dot data is error status whatever because we are wrapping the results in use query right now. And if I refresh the page, yeah, then it result, I mean we have basically created a generic wrapper right now using use query. And yeah, I mean, I guess I could go to the types of this as well. Like we can actually sort of type this correctly in a way so that it returns the correct types on it, which it's basically a wrapper called queryify results, which wraps around the Octokit object, but it can wrap over, you can use a generic and then wrap it over whatever object that you're passing in and make this a generic method. And so that is how we sort of get this then in the end. Like you can use all of your methods and then get data is loading an error, all of the use query constructs along with all of the benefits like caching, fetching, everything else on any object. So yeah, I guess that was my talk, and thank you.
Just one question. Why did the key have to be an array? Does it have to be an array? But
it can be anything, but I think it's better if it's an array because then you can have it be really unique because you can pass multiple elements in. If you use the same query key, then it will sort of try to, I guess, store the same result for multiple different API calls, which doesn't make sense because then your cache won't be of any use, I guess. If anyone wants to ask questions about object proxies or like creating generic methods like that, feel free to reach out on thewriting.dev or at thewriting.dev. And yeah, we do Svelte meetups every month. The next one's on 21st June, so feel free to join if you wanna.